Our sun might feel massive to us here on Earth, but what if we told you there's a star so immense, it makes the sun look like a tiny speck of dust in comparison? NASA has recently uncovered one of the largest stars ever discovered, and its sheer size and power are absolutely mind-boggling. This discovery isn't just a jaw-dropper, it's reshaping how we understand the cosmos and the limits of star formation. But here's the part that will blow your mind. This colossal star is so gigantic it could fit nearly 10 billion suns inside it, yet scientists believe it's nearing the end of its life, setting the stage for an explosion that could outshine our entire galaxy. Stick around to learn how this titanic star compares to others, what makes it so unique, and what its impending fate could mean for our understanding of the universe. Imagine a warm summer day at the beach. You hold a beach ball in your hands. It feels large, significant, the centerpiece of your game, but now look around at the vast ocean and the miles of sandy shore. Suddenly that beach ball seems insignificant. Now picture our sun. This fiery, life-giving star is our cosmic beach ball, but in the grand tapestry of the universe, it's barely a grain of sand. For centuries, humanity has been fascinated by the stars. From ancient civilizations mapping constellations to modern astronomers unraveling their secrets, we've always looked up, searching for answers. And while our sun might be the cornerstone of our solar system, among the stars, it's average, perhaps even modest. But what makes a star colossal? And how does NASA even begin to find these cosmic giants? The journey starts with humanity's relentless pursuit of knowledge. Using powerful tools like the Hubble Space Telescope and the more recent James Webb Space Telescope, astronomers peer deeper into the universe than ever before. These instruments detect faint light from stars billions of light-years away, analyze their size, and even estimate their mass. Specialized instruments, like spectrometers, help scientists understand a star's chemical composition and brightness, key indicators of its true size and power. It's through these technologies that NASA began its quest to uncover the largest stars in existence. The search for the largest stars isn't just about size, it's a quest to understand the extremes of physics, the boundaries of creation itself. These stars hold secrets about how the universe evolves, how galaxies form, and even how life as we know it became possible. But NASA's recent discovery? It's not just big, it's colossal. The kind of discovery that reshapes our understanding of scale. Can you imagine a star so vast it makes the sun look minuscule? Now let's dive into the astonishing details of this incredible discovery, the behemoth that challenges everything we thought we knew about the universe. Hidden deep within the vast expanse of the cosmos, in a distant galaxy millions of light-years away, NASA has uncovered a true cosmic marvel, a star so enormous, so incomprehensibly massive that it redefines what we thought was possible. This isn't just another star, it's a cosmic titan that could fit billions of suns inside it. Let that sink in for a moment. Meet Stevenson 2.18, a red supergiant located in the constellation Scutum, roughly 20,000 light-years from Earth. With a radius nearly 2,150 times that of our Sun, this star is the largest we've ever discovered. If Stephenson 2.18 were placed at the center of our solar system, its outer layers would stretch far beyond the orbit of Saturn, engulfing the planets and leaving no trace of the familiar cosmic neighborhood we know. It's a scale that is almost impossible to comprehend, a true behemoth among stars. But here's the real question. Why did it take us so long to discover something so gigantic? The answer lies in its distance, its location, and its nature. Stephenson 2.18 resides in a dense stellar cluster surrounded by interstellar dust which obscures it from view in visible light. It was only through advanced infrared and radio observations, using instruments like the Very Large Telescope in Chile and NASA's Hubble and Spitzer telescopes, that astronomers were able to peer through the cosmic fog and uncover this massive star. When compared to other known giants, Stephenson 2.18 towers above them all. Stars like Betelgeuse and Antares, once considered massive in their own right, seem diminutive when placed beside this red supergiant. Even UY Scuti, previously regarded as the largest known star, is dwarfed by Stephenson 2.18's immense size. It's not just a larger star, it's a completely new benchmark for the scale of stellar formation in the universe. So, why is this discovery so important? Stars like Stephenson 2.18 push the boundaries of astrophysics, challenging our understanding of how stars form, evolve, and eventually die. And as we dive deeper into its mysteries, one fact becomes abundantly clear. This isn't just a star. It's a story about the unimaginable grandeur of the universe itself. Next, we'll uncover what makes this star so unique and how it's nearing the end of its titanic life cycle, setting the stage for a cosmic event that could outshine everything in its galaxy. When it comes to Stephenson 2.18, the term big feels laughably inadequate. This isn't just a large star, it's an unfathomable cosmic leviathan. Let's break it down. With a radius nearly 2,150 times larger than our Sun, it's difficult to wrap our minds around its sheer scale. But picture this. If the Sun were the size of a basketball, Stephenson 2.18 would be as massive as an entire football stadium spilling over into the parking lot. And that's just its radius. The volume of this star? It's mind-boggling. To put it into perspective, Stephenson 2.18 could fit nearly 10 billion suns inside its boundaries. Yes, billion, with a B. Imagine filling every stadium on Earth, not just once but countless times, with suns. That's the scale we're talking about. Its vastness dwarfs anything in our solar system, stretching well beyond the orbit of Saturn if it were at our system's center. But how do scientists measure the size of something so far away? It's not as simple as holding up a ruler to the night sky. Astronomers rely on light. They measure the star's brightness, color, and the light curves emitted from its surface. By comparing this data to models of stellar physics, they can calculate its radius and luminosity. Infrared telescopes in particular are crucial for peering through the dust clouds that often obscure these giants, revealing their hidden grandeur. This raises an intriguing question. Could something this colossal even exist within the known laws of physics? The answer lies in the delicate balance between gravity and radiation pressure. A star as massive as Stephenson 2.18 exists at the very edge of what physics allows. Gravity pulls inward, attempting to collapse the star, while the outward pressure from nuclear fusion within its core pushes back. For a star this size, that balance is incredibly fragile, and it's part of why Stephenson 2.18 is nearing the end of its life. Its immense size also raises questions about its formation. How could a star accumulate such vast amounts of material? Scientists believe that Stephenson 2.18 was born in a densely packed stellar nursery, pulling in gas and dust at an extraordinary rate during its early years. Over time, it grew to its staggering proportions, becoming a rare and extraordinary phenomenon in the universe. And yet there's something humbling about such immensity. It forces us to confront the true scale of the cosmos, one where even the most colossal objects are but specks in an infinite expanse. As we move forward, let's explore what makes Stephenson 2.18 so unique and why its days, despite its size, are numbered. What makes a star defy normal limits to become a cosmic colossus? The answer is as complex as the universe itself. Stephenson 2.18 belongs to an incredibly rare class of stars known as red supergiants, or more specifically, a hypergiant. These are the heavyweight champions of the cosmos, stars so immense that they push the boundaries of physics. But how does such a star come into existence, and what fuels its staggering size and luminosity? The story of Stephenson 2.18 begins in a stellar nursery, a dense region of gas and dust where stars are born. In these regions, gravity takes the lead, pulling together vast amounts of hydrogen and helium. But in the case of a hypergiant like Stephenson 2.18, the conditions were extraordinary. It likely formed in a cluster rich with material, allowing it to accumulate mass at an unprecedented rate during its early years. As it grew, nuclear fusion ignited in its core, creating the outward pressure necessary to counteract the immense gravitational forces pulling it inward. This balance of forces is what maintains the structure of any star, but for a hypergiant, the scales are far more extreme. Gravity attempts to collapse the star under its own mass, but the immense energy released from the fusion of hydrogen into helium at its core pushes outward, creating a tenuous equilibrium. However, this balance is fragile, especially for a star as large as Stephenson 2.18. The sheer amount of energy it radiates, nearly 440,000 times that of the Sun, means it burns through its nuclear fuel at an astonishing rate. The luminosity of a star like this is one of its defining traits. Its surface temperature is lower than smaller stars, giving it a deep red hue, but the sheer size of its surface area makes it incredibly bright. To put it in perspective, if Stephenson 2.18 were located at the center of our solar system, Earth wouldn't just be uninhabitable, it would be vaporized almost instantly. Yet its immense size comes at a cost. The star is unstable, shedding its outer layers in violent stellar winds. Over time, this mass loss accelerates, signaling the end of its life. Stevenson 2.18 is essentially living on borrowed time, a giant burning through its remaining fuel in a cosmic race against collapse. Stars like this are rare because the conditions required to create them are so unique. They also provide a glimpse into the extreme ends of stellar evolution. Hypergiants like Stephenson 2.18 challenge our understanding of astrophysics, especially the limits of how much mass a star can hold before gravity takes over completely. As this titan nears the end of its life, it will leave behind more than just questions. Its death will be an event of galactic proportions, likely resulting in a supernova so bright it could be visible from Earth even during the day. But what happens after that? In the next section, we'll explore the epic finale awaiting Stephenson 2.18 and what it means for the future of its galaxy. If stars like Stephenson 2.18 exist, how small does that make us in the vast, indifferent universe? It's a humbling question, one that forces us to reflect on our place in the cosmic order. This discovery doesn't just redefine our understanding of size, it reshapes how we think about the processes that govern the stars and galaxies around us. For astrophysicists, Stephenson 2.18 is a treasure trove of information. It challenges existing models of stellar evolution, pushing the boundaries of what we thought stars could achieve in size and scale. Stars like this offer rare insights into the later stages of a star's life, showing us how hypergiants live fast and die young. Their immense mass and luminosity mean they burn through their nuclear fuel far more quickly than smaller stars, accelerating their journey toward an explosive end. By studying Stephenson 2.18, scientists can refine their understanding of how these titans form, evolve, and eventually collapse into supernova, or even black holes. But perhaps the most intriguing implication is the possibility of finding something even larger. Stephenson 2.18 is the biggest star we've discovered so far, but the universe is vast, and our tools are still limited. Could there be other cosmic leviathans hidden in the farthest reaches of the cosmos, waiting to be uncovered? This star reminds us that the universe is full of surprises, and with each discovery we're only scratching the surface of what's out there. On a more philosophical level, stars like this shift how we see ourselves. Earth, with all its beauty and complexity, is a fragile speck in an immense and chaotic universe. Our sun, the giant in our sky, is little more than a grain of sand when compared to a star like Stephenson 2.18. This perspective is both humbling and inspiring. It reminds us of how small we are, but also of the incredible human capacity to explore, discover, and understand. In the grand scheme of things, stars like Stephenson 2, the 18th of May, seem indifferent to our existence, but they also tell a story of creation, destruction, and renewal. Their lives shape the cosmos, seeding galaxies with the elements needed to create new stars, planets, and even life. In a way, we owe our existence to stars like this, giants that burned brightly and then died spectacularly, scattering the building blocks of life into the universe. As we continue to explore the cosmos, discoveries like this serve as a reminder of both our insignificance and our potential. They challenge us to ask bigger questions, to push the boundaries of what we know, and to marvel at the sheer scale of the universe we call home. The story of Stephenson 2.18 doesn't just end with its discovery, it's an ongoing journey of understanding, one that will shape astronomy for decades to come. And perhaps in studying this cosmic giant we'll learn more about our universe, our origins, and our future in the stars. Imagine a star so big that its surface would engulf Mercury, Venus, and even Earth. Could we even comprehend its power? Let's take a moment to picture the unimaginable. What if Stephenson 2.18, this cosmic colossus, replaced our sun at the center of the solar system? For starters, Earth as we know it wouldn't stand a chance. With a radius nearly 2,150 times that of the sun, Stephenson 2.18's outer layers would stretch far beyond the orbit of Saturn. Mercury, Venus, Earth, Mars, all would be swallowed whole by the star's immense size, reduced to little more than vaporized debris in its atmosphere. Even the outer planets, like Jupiter and Neptune, would experience catastrophic effects. The intense heat radiating from this red hypergiant would incinerate everything in its vicinity, making life in any form impossible. And it's not just the size that would wreak havoc, it's the gravity. The gravitational pull of a star this massive would completely destabilize the delicate balance of our solar system. Orbits of remaining celestial bodies would spiral into chaos, with planets either flung into the void of space or drawn inexorably toward the star. The asteroid belt would be obliterated and comets from the Oort cloud would rain down into the inner solar system, pulled in by Stephenson 2.18's overwhelming gravity. But let's say, hypothetically, that Earth wasn't completely engulfed by the star. Could life exist near such a behemoth? The short answer, no. Even if Earth somehow managed to remain at a safe distance beyond the star's fiery grasp, the heat and radiation would make the planet utterly uninhabitable. Temperatures would skyrocket far beyond the boiling point of water and the atmosphere would be stripped away by intense stellar winds. The planet would be reduced to a barren molten wasteland, if it survived at all. Even the very concept of day and night would cease to exist. The star's size would dominate the sky, stretching across the heavens in a fiery crimson expanse. Its light wouldn't just illuminate our world, it would consume it, rendering the boundaries between night and day meaningless. In truth, nothing in our solar system would remain recognizable. Stevenson 2.18's presence would completely rewrite the fabric of our cosmic neighborhood, leaving behind a desolate and uninhabitable system. It's a stark reminder of the delicate balance that allows life to thrive on Earth, a balance that depends on the sun's relatively modest size and stability. The thought experiment is both awe-inspiring and humbling. It highlights the incredible power and scale of hypergiant stars like Stephenson 2.18 and underscores just how fortunate we are to exist in the orbit of a star perfectly suited to sustain life. As we gaze at the stars, it's worth remembering just how vast and varied the universe is, and how stars like Stephenson 2.18 reveal the extremes of what's possible in the cosmos. Stephenson 2.18 isn't just a discovery, it's a reminder of how little we know and how much is left to explore in the cosmic abyss. This colossal star, as incomprehensibly massive as it is, might not even be the largest. Could there be even bigger stars hiding in the distant corners of the universe, concealed by dust clouds or simply too far away for us to detect? The truth is, we don't know. And that's what makes this discovery so thrilling. It opens the door to questions that could take generations to answer. NASA and other space agencies aren't stopping here. Tools like the James Webb Space Telescope, designed to peer deeper into the cosmos than ever before, are paving the way for even more astonishing discoveries. These instruments could uncover stars larger, brighter, or older than anything we've seen so far. Missions in the coming decades will explore the outer reaches of the galaxy, mapping regions of space previously beyond our reach. As technology advances, so too does our ability to decode the mysteries of the universe's giants. But this isn't just about the science, it's about inspiration. Discoveries like Stephenson 2.18 spark a sense of wonder that transcends generations. They remind us that the universe is vast, full of extremes that challenge our understanding and stretch the boundaries of human imagination. For young astronomers and curious minds looking to the night sky, these discoveries are a call to action, a reminder that there's still so much out there waiting to be uncovered. And it's not just about stars. These cosmic titans hold clues about the very fabric of the universe. Their lives, from their fiery births to their dramatic deaths, shape galaxies, scatter the elements necessary for life, and fuel the endless cycle of creation and destruction. They are not just objects in space, they are storytellers, narrating the history of the cosmos. As we reflect on Stephenson 2.18 and its staggering scale, one thing becomes clear. Our journey of discovery is far from over. The universe is vast and ancient, and every discovery is a small piece of a much larger puzzle. What lies beyond Stephenson 2.18? What other cosmic wonders are waiting to be found? These questions remind us why we explore, not just to understand the universe, but to find our place within it. So as we continue to gaze at the stars, let us do so with a sense of awe, curiosity, and a drive to push the limits of what we know. Because if there's one thing Stephenson 2.18 has shown us, it's that the universe still has secrets to share, and we're only just beginning to uncover them.